Welcome back to the show, guys. It's great to be back. I've been away for a few days and I'm excited to get back on it. So welcome back to the show. Do all those amazing things. Say hi in the comments. Like, subscribe. You know what to do. Really appreciate it. We're a young channel. Exactly. So we're here bringing you the latest news in AI. For those who are new to the show, we work in that space. And we thought, what better way to keep up to date, because it's such a fast moving pace, but to keep an eye on the news, talk about it, share our views, and maybe just occasionally share what we're doing in this space as well. But Will,
absolutely,
what's the latest in the AI news today? It is Monday. It is first thing in the morning. No, it's not. It's either. It's not even Monday.
It's Tuesday. And when everyone sees this, it will be Wednesday.
Oh, jeez. I've been a little bit out of it, haven't I? So. Back on it, back on the wagon, back on the horse. Let's do it.
Welcome back. We have missed you. Obviously, last week you saw a couple of videos come from Matt and I. Obviously, we couldn't replace Ben's presence. Matt and I's personality added together doesn't add up to Ben's personality.
All the flattery. Oh my goodness. I'm
we tried
now.
Matt and I tried.
Don't listen to a word, guys. Guys, don't listen to a word. It's all untrue. Believe me.
Let's jump in. And tired or not, I've purposefully, just because you are tired, picked a fairly heavy academic story today, but it is pertinent to what we do, and I'll do my best to explain why it's important and try not to bore everybody. It's an ex-post sharing a research paper, which is already a bad sign for most people, when you load up a research paper. But this tackles, and I'll explain very simply, something that we've spoken about a lot is how we can use small local AIs to do tasks on your computer, on your device, and keep everything 100% private and in your control. This is a massive problem to solve, fundamentally, because small models are typically very poor compared to what people are used to using their larger counterparts.
Yep.
And their margin of error is just ginormous. Even in the frontier models, their error rate is 99, is still very small. But over a long horizon tasks, it just becomes impossible to complete that task without error. And this is obviously a massive problem. And then smaller models, it's the same problem. So this research paper is interesting based on, it's an ex-post. I don't have the research paper to scroll through, but I have the ex-post talking about it. And it is fascinating. It's a fascinating read. And it's a suggestion on how to improve this. And the research paper goes over, I think it's a Chinese lab that managed to do a 1,000,000-step problem with 0 errors. Now, basically, a 1,000,000-step problem, a step is basically as you'd anticipate. If there's a task, you can break it down into steps, and each step, will get you towards that end goal. So, for example, read a file on your computer. The first step would be to search the file for that computer. On that computer, the second step would be to then open that file. The third step would then be to return the contents of that file. So that's a 3-step problem. Here we have a 1,000,000-step problem, which is statistically considered impossible. But this lab, this research has done it, and how they've done it is really interesting. Any questions so far, Ben?
No, I'm just taking it in. I mean, that just sounds like mind-blowing, but to be honest, this whole space is mind-blowing. It's just...
It's amazing.
You want to look into the future, just keep an eye on this space and, listen to the show, because we're literally talking about this stuff every day, and it's just, it continues to... I mean, we're working in this space, but it continues just to blow my mind. And I think it's just, we can't begin to imagine we can begin to imagine what the world's going to look like in 10, 20 years, but it doesn't feel real. It feels like, surely not. Surely,
absolutely.
It's so far. It feels like a 1,000-year jump that's going to happen in 20 years. That's what it feels like. So, absolutely. Mate, that's exciting. It's fascinating because obviously we're working with, our things with small models. So,
and how they've done it is what is really fascinating to me. Most people think that what you need to do, and the thinking thus far has been overwhelmingly, we need to make these models bigger and smarter and give it more compute, give it more data, and it will keep getting better, which is true. But what we've also found is that is getting literally harder and harder to do. The scaling law keeps going, but the resources required, we're getting to a point where we can't obtain it anymore. So what they've done to solve the problem is that they use small models, tiny models, really. It doesn't have to be a frontier model at all, and it breaks a problem down. So one model will break the problem down into the most minute number of steps it can do. So that read file and tell me what the contents example I gave you, they break that down into more than 3 steps, tiny little tasks that are really easy to accomplish. And that might be 100 tasks to get to that point, but each of those tasks is so ridiculously easy that any model can go and achieve that. What it then does is it orchestrates a team of models, loads of them, that will all try and solve that one problem. And when they have, they'll come together, and it's obviously, I'm talking very abstractly to how this works. They'll come together and vote on a consensus of what the answer is. And
that's wild.
What this allows you to do is, and the most popular answer, the most correct answer, is the one that will then proceed with that step. And what that allowed this research paper, and there's more validation to do, and you don't have to take it at face value. But what it's been purported to do is then they were able to solve a million step problem without any errors because of this sort of consensus voting mechanism and the steps being small enough that any model can achieve it. Now, that is incredible. I absolutely love that because it achieves what we want to achieve personally and within our business goals and on our personal goals, but also it does it in exactly the way that we want to do it. And I'm not saying this is something we can roll out tomorrow, but it gives a new direction, a new architecture to think about. Instead of hiring a massive genius, the world's leading expert, and putting him on the task alone, it's like bringing in an entire team of people, all experts in their domain. They might not be the best in their field, but they're knowledgeable enough and they work together and they can actually outperform the best in the world. So that's what it likens it to. So no, fascinating. It's a little bit nerdy. Research papers are heavy for a Tuesday morning, but I just thought it aligned so well with what we're doing that it was worth talking about.
Well, mate, 100%. It's absolutely phenomenal because like you said, it's one of the downsides of micro models. We're looking at models on device models, and the output is never going to be able to compete with a ChatGPT because it's on device, it's tiny model, it's not calling the internet, there's limited, I guess, intelligence. But what you get with that is self-sovereign AI. And as technology evolves and as these solutions emerge and people start pushing the boundaries and exploring what is doable with these models, I mean, again, it's going to be interesting, isn't it, to see how these tiny models catch up. And then at some point there's going to be an inflection point where is it going to be that noticeable between whether you're using a tiny model and a frontier model? So whether that's going to be interesting. Is that going to happen in 5 years? Is it going to happen in 6 months? No doubt
absolutely.
there will be a difference, but you do wonder where this sort of landscape is going to take us, because I'll pivot slightly. I mean, there's all this investment into the picks and shovels of AI. So, for example, investment into energy companies, not just the AI, obvious ones, the AI models themselves, but the actual, the energy companies, and what have you. And you think, well, what happens if we don't need all this energy, or actually there's suddenly an abundance of energy and the models are getting so good it's not, yes, you may still need that frontier technology for enterprise, but for mainstream users, so it's just interesting, so whether there's going to be a bust at some point with some of those sort of energy companies. I don't know. It's so, we just don't know what's going to happen. And, so it's almost like the Betamax and the VHS. Was it Betamax and VHS? Something like that. It was, you had these sort of two technologies. I think Betamax was the better one apparently, but VHS won it and they died. So there'll be a lot of that, I think, over the next, 10 years, 5 years. Who knows? So
well, these smaller models. Yeah, these smaller models are already getting very, very good to the fact that we're shipping it within our apps, and we just released one a few days ago that is already doing very well. That ships it on device, which is great.
I know. Will,
that.
Sorry, Will. I was just going to say, do we tell the audience yet, or should we keep it a little bit hush hush?
I think that we should do a dedicated episode showing it off. Okay. I think it's so good. I know we've built it, but I think it's so good that it would do it a disservice just to casually just show it now. In amongst this, it's more important.
Well, let's be honest. Most YouTube viewers have attention span of a gnat. So if anyone's still watching this, you didn't have a little inkling that we even gonna even give you a snippet. Good YouTubers, not like us, by the way. Good YouTubers would say, "Oh, keep watching till the end because I'm going to share something." We didn't do that, but we're obviously amateurs. Maybe
we're very much amateurs.
We very much just jump on and go, right, what are we talking about? Okay, that's cool. Let's talk about this.
I think we'll do a dedicated episode and we'll show it off. But the technology itself, basically, we're at a point now where for a lot of users, it is indistinguishable. They're not going to get any different an answer or a very similar answer to what they would get from GPT-5. But this model is tiny and it runs on your phone and the data never leaves, no internet connection required. But we'll show it off. And these models are getting smaller and better anyway. For example, we also developed nanocoder, which we have talked about before, and we should show that off as well at some point. But we're now getting to a point where we're getting really good coding abilities and long horizon task following from models that are 20B in size. So that is good enough for consumer hardware. Yes, you need a very good laptop for it, but you can run it completely locally and do coding to a fairly decent degree. And we're making leaps and bounds of progress in that field as well. So there's going to be this point where 100% that we're not going to need frontier models. Small models are going to cut it absolutely fine for 99% of our tasks that you and I would ever need to do personally. And then, yes, there's going to be frontier technology for all sorts of things that is far too intelligent for us to ever need to know.
Wow, listen, let's wrap it up, guys. On that note, let us know what you think. Let us know anything you want to share. What's your thoughts? How do you see this playing out? It'd be great to sort of, get your perspective, or even if you just want to say, hey, how you doing? Say that in the comments. That's always nice. But as usual, keep tuned in. We're going to keep bringing you the news and share our views and opinions on all the latest that's happening in this space. So it's an exciting place to be. Keep joining us as we build in this space and also keep an eye on what's happening. So hope you enjoy it. Absolutely. Keep tuned in and we'll catch you on the next one, guys. Take care.
Catch you in the next one.